Okay, so I think we can start. Okay, so you had class just now from 11 to 12. Okay, so can you hear what I'm saying? Can Okay, so let's we continue. Okay. So so far we learned about prefixes. So after prefixes, we just continue what is left. Okay. The next part of the lesson is, can you hear me? Everyone?
Yes.
Can Okay, so
Yes.
next part, we have another two part. Now the next part is going to be a little weird one. Okay. Reasonable estimates we call. As a Cambridge student, the Cambridge want you to have a very good estimator. You must estimate surrounding you. Like estimate means estimate, for example, like this. Okay, looks weird, Like, what is the mass of a jar of peanut butter? Estimate. How many gram? Or is it going to be kilogram? Can you estimate one? What is the mass of a jar of peanut butter? Is it going to be kilogram? Is it going to be gram? So you need to give a value. Anyone?
Grams.
So it's around, yeah, it's in grams, around 500 grams. Cambridge, if this question comes out in exam, they'll give a wide range. They might give maybe from 200 gram to maybe 1 kilogram. So we're going to be a very wide range. If you never fall in the range, that means you are a very poor at estimator. Okay. So you need to estimate surrounding you. Okay. For this, you need a very good general knowledge. You must be alert to the surrounding. Okay. I go further. What is the length of a car? Anyone? 4 meters? 3 meters?
4 to 5 meters.
5 meters, around 5 meters. 5 meters, like maybe or maybe 3.5 meters. So I think 5 meters is our estimation, 4 to 5. Okay, they'll give a range. Of course, won't be 1 meter. So anyone give 1 meter, of course, you are a poor estimator. We said 8 meter or 9 meter, quite long enough. Okay, so you must be a good estimator. Okay, let's do further estimation. Next one. Anyone? What is the diameter of an air? A piece of air.
1 m.
M, about micrometers. Under micrometers. Okay. So micrometers. S around micrometers. Next, diameter of an atom. It's negative 10 meter. Atom and nucleus. You will learn this in the last topic 13 about nucleus. So then you will get to know this diameter of an atom. Negative 10. It's a fact to remember. Diameter of a nucleus is anyone? 10 power of negative 15 meter. A fact to remember. Okay, these two you need to remember. Memorize it. Okay. So this estimation just goes on. Okay. Next page, I have a very long list. Let's we estimate. Yeah, I give you 2 minutes for you to estimate. This is the one. Okay. 2 minutes for you. Get your readings first. Mass of an orange. Anyone? Kilogram? Gram? Good. If you go to the market, you buy 1 kilogram of orange. How many orange they're going to give you?
80 grams.
50 gram. Yeah, 50 gram means 1 kilogram. You'll get about 20 oranges. I think 1 kilogram you get 5 to 6 oranges. 5 to 6. I think around 200 gram estimation. But I tell you, in Cambridge, the range they give of orange is from 50 to 500 grams. Those who say, those in your mind, it's from 50 to 500 gram. Okay, you are still okay, your estimation. Less than 50 grams is wrong. I think the good answer is around 200 grams. You get 4 to 5 oranges, 1 kilogram. Okay. So those who went to the market, bought 1 kilogram of orange or apple, you might estimate this. Okay. Next, a mass of an adult human. This you should know.
75.
Around, from maybe 60 to 100. Good estimation. 75 is a very good reading. Yeah, 75 kilogram, not more than 150 or not less than 30 or 20. 75 is a good. Yeah. So see the height of a room in a house. Hard to
4 meter.
4 meters.
Three.
3 meters.
3 meters is quite low. Maybe 4 to 5. 4 also quite low. I think 4 is okay. 4 to 5 meters lah. Height of a room. Okay. Diameter of a pencil
1 cm.
around 1 cm or less than 1 cm, maybe 8 mm. 1 cm, 1.5. Not more than 3 cm, I think. Volume of a tennis ball. Volume of a tennis ball. Anyone? What formula must come to your mind?
10Q.
4 3. Okay, R cube. Kind of a little calculation. So pi how much?
Yeah.
Your R how much? Radius?
5, I think. Is it 5?
5 is your diameter. 5 centimeter diameter. Maybe 3
Of
centimeter of radius. So 0.03. 3 squared.
Oh,
Cube, sorry, not square. Cube. So you get your meter cube. How much roughly? Or 3 pi 0.03 cube. 5 times. 5 times. 5 times 5. Around 25 or maybe 0.125. Anyone? Meter cube?
1.1
1.1
times 10 power of -4.
-4. Okay. So it's just kind of estimation, centimeter. Okay.
Teacher, regarding pi, so we use the value 3.142 or the whole symbol of
3 as 3.14.
Okay.
Okay. Next, this is interesting. This came out in the past year of Cambridge. The volume of a human head. Come on, this is interesting to estimate. Come on, some of you can estimate in terms of centimeter cube, maybe. Let's see this. Who can estimate? Is it 100 centimeter cube, 1,000 centimeter cube, 10,000 centimeter cube? Which one? Reasonable. 100 centimeter cube, 1,000 or 10,000 in centimeter cube. Oh, 100,000.
On 100 centimeter cube. Wait, no.
100,000, 10,000, 100,000. Which one? You can measure what is your head, so you can measure the length, width, and the height. Treat it as a cube, maybe a cubeboard, so you can get a rough idea. So 100,000, 10,000. The length of your face is how much? Around maybe 15. So 15 times 15 times 15 maybe. 15 times 15 times 15. 15 centimeter, quite big. It's okay. This is number one. 15 cube, what do you get?
3,300
3,300
cent.
3,000 something lah. So yeah, around maybe 3,000 to 4,000 centimeter cube. 4,000 centimeter cube. So those who go for 10,000 is wrong. Less than 1,000 also not doesn't make. I think 3,000 centimeter cube makes sense. 15 times 15 cube. Okay. I tell you the truth. You don't worry about your estimation. If your estimation is reasonable, the Cambridge is going to give a very wide range. They give a very wide range. If you never fall in their range, means you are really not a good estimator. You never observe the surrounding. The next weight of an apple?
A Newton.
How many Newton?
1 Newton.
1 Newton. 1 Newton means you go how many gram? The mass of an apple? Around 100 gram. 100 gram, right? Okay, makes sense. 100 gram times 9.81, you got around 1 Newton, let's say. 100 gram. So 200 gram, I think best choice. 200 gram is 0.2 times 9.81. A level must use gravity 9.81. 9.81 times 0.2, what do you get? That's, I think it's a good estimation. 0.1 Newton, not bad. Okay. Yeah. So in your mind, apple is around 200 gram, spot mass of the orange. Okay. So 2 Newton, maybe. Walking speed. What is the speed you walk? How many meter per second? How many meter you travel in a second? Anyone?
1 meter per second. Be reasonable.
Yeah. 7 meter per second. What is the speed of the Usain Bolt? Run 100 meter.
Maybe this
Usain
1
Bolt.
point. This.
Usain Bolt, the world record how much? 9.52 or 56. 9 point, about 10 seconds, let's say. 100 meter, you spend around 10 seconds, Olympic runner. So what is the average speed? 10 meter per second, right? 10 seconds to 100 meter. So 10 meter per second. Olympic runner, 10 meter per second. What is the walking speed? Walking speed. How many meter you can travel in a second, roughly? 1 meter?
2
meter. 2 meter. Okay, 1 meter per second, 2 meter makes sense. Of course, definitely not more than 10 meter per second. It's wrong. I think 1 meter reasonable. 1 meter, 2 meter per second. You walk fast, I think 2 meter per second. Okay, so you need to be a good estimator. Cambridge, of course, they're going to deny if you put more than 10 meter per second. Even Olympic running is 10 meter per second. So 2 meter per second, 1 meter per second makes sense. If that is in your mind earlier, good. You are a good estimator. Okay, next. Jet. Speed of a jet. Anyone? How many meter per second? How many meter?
500
Yeah.
meters per hour.
Hundreds, thousands meter per second. What is that?
1,000 kilometers per hour, maybe.
Yeah, 1,000 kilometers per hour. Yeah, maybe around less than 300 meter per second. Less than 300 meter per second. Less than 300 meter per second. Okay, expected value. Okay, 300 meter per second. You times with 3.6. Close to 1,000 kilometer per hour, maybe. Okay, speed of jumbo jet never exceeds speed of sound. Jet never exceeds speed of sound. What is the speed of sound around? Around 320 kilometer per second. Okay, that's also another estimation. Speed of sound 320 to 330. 300 to 330. So jet never exceeds speed of sound. 300 meter per second. Reasonable estimation. Temperature of a human body around 30, 36, 37. 37 degrees Celsius. Okay. So the conclusion is what? You must be a good estimator. Okay. Recent past years, I came out, they asked, what is the mass of a protractor? Anyone? What is the mass of a protractor? 50 gram? 10 gram?
10 gram.
10 gram.
Wait, so
The estimation given by Cambridge is less than 50 gram. And value less than 50 gram. 10 gram will do. Okay. More questions? They ask, what is the atmospheric pressure? How many Pascal? Anyone?
300,000 pascals. Is it?
300,000 Pascal.
Is that what?
Atmospheric pressure is 100,000. It's 100,000 Pascal.
Oh.
Okay, 100,000 Pascal. So today onwards, for your 1.5 years of course, so you have to be quite alert to the surrounding. That is, here they ask, what is the power of a light bulb? Anyone? What is the power of a light bulb?
10 watts. 10 watts.
10 watts. Yeah, the one I bought last week, I think it's 15 watts, 10 watts. Yeah, makes sense. Never exceeds more than 50 watts. 50 watts also is a very powerful one. So less than 50 watts. Okay, a reasonable estimation. Okay, conclusion is you must be a good estimator. Okay, I don't know what they're going to ask. 1 year they asked, okay, this is a very good question. Okay, let me show you that question. Go back. 1 year they asked, okay, I just tell you here. What is the kinetic energy possessed by an Olympic runner? Good question. Come on, give a try. What is the kinetic energy possessed by an Olympic runner? 1,000 joule, 100 joule, 1,000 joule, 10,000 joule, 100,000 joule. Which option? Closest.
You can do calculations, right?
Yeah, you can do rough calculations. Man. What is the kinetic energy possessed by an Olympic runner? 100 joule, 1,000 joule, 10,000 joule, 100,000 joule. Sure.
3,000.
You go for 3,000. Okay, 3,000. See, 3,000. So why 3,000? So formula must come to your mind, of course, half mv squared. So you need to estimate the mass and v. What is the mass you estimated? Around maybe 80 kg. 60 kg also can. Speed. What is the speed of Olympic runner? As I said, 10. 10 squared. So it's about around 4,000 thousands. Thousands. So those who say 10,000 consider wrong. Cannot be 10,000 joules. 4,000 joules, 3,000 joules makes sense. Okay, so good estimator. It's a 5 to 6 marks question. Okay, in exam. How frequent it comes out? Maybe 3 years once it comes out. 3 years once. Yeah, didn't tell. Your year, if you are, I don't know whether you are lucky or unlucky, it's going to be a first structured questions with the 5 to 6 marks. So estimation. Okay. So we move on. Okay, next, last part of the topic is vector scalar. Okay. So I believe you learn about vector and scalar. What is vector? A quantity has a magnitude and direction. Scalar is only magnitude. Okay. So now we go to the list earlier. Okay, I think I go back to the original list. That's the list. Okay, yeah. Come on, let's do together. Tell me, is it a vector scalar? From the on top. Frequency.
Scalar.
Scalar, no direction. They don't have direction. Velocity.
Vector.
Vector, it has a direction. 5 meters per second to the north. So you have to tell the direction. Velocity. Speed, no direction. Acceleration.
Vector.
Vector has a direction. The car accelerates to the right, to the left. Yes, you have to tell the direction. Force.
Vector.
Vector also. Energy.
Vector.
Energy is vector. Do you have the direction for energy? I used 20 joule of energy to carry the table. I did 50 joule of energy. I did a workout. I found around 20 joule of energy, kind of. Do you need to tell the direction? To the north, to the left?
No.
Not necessary. Energy don't have direction. So it's a scalar. Energy is a scalar. Power? Do it as a direction. Like for example, you try to put the wording. The power of the engine of the car is 20,000 watts to the north. Is it sounds funny or it makes sense?
It's funny.
Funny. So power is don't have direction. Therefore, it's a scalar quantity. Don't have direction. Okay. Power is rate of doing work. No direction. Charge.
Scalar.
Potential difference, voltage,
Scalar.
scalar. Voltage also a scalar. Work done per unit charge is a scalar. Resistance,
Scalar.
scalar. Density,
Scalar.
scalar. Pressure,
Scalar.
this is a controversial scalar. Pressure is a scalar quantity. They don't have a specific direction. It's like all directions. So we categorize it as a scalar quantity. Okay. So vector scalar. Okay. Okay, good. So we go back. We learned this before. So now we go to the advanced stage of vector scalar. Okay. Yeah. So the car speed is a scalar, velocity is a vector. This is a group of quantities which is characterized as scalar and vector. Do you have some new quantities in the list too? What are the new quantities? Field. All the fields are vector. Gravitational field, electric field, all as direction, they consider as vector. Okay. We will do in depth about these three later. Okay. Momentum not in the list is a vector. Okay. So yeah, weight is a vector. Someone confused with weight and mass. Weight is a vector, mass must be a scalar. Okay. The term torque, you will learn that later. Something new for SPM students. Okay, so vector scalar. Okay, so recall back. Any quantities quite you feel should be the other way around in the list? All make sense? Okay. So this is vector and scalar. Okay, let's see, move on. Okay. So vector quantities can be added one after another. So this is like V, you put V, another V, it's going to be 2V. It's vector addition. Then you reverse it, V, you reverse it, it's considered as negative V. V, you make it half length, and it's half V. Your additional maths knowledge. A vector, if magnitude you want to double up, you can double up, just increase the length. If you want to convert the direction to opposite, you just draw down. Okay. If directed upwards means the negative of that vector is down. You learn this right before. Okay. Okay. So yeah, see here A and B. So you can add them. Two vectors can be added, A plus B. How do you add them? The tail, the head of the first vector added to the tail of the second vector. Connect them, added. So it's A plus B. Okay. Tell me, is it A plus B same as B plus A?
Same. Right.
Is it A plus B same as B plus A? Is it same or not same? How did you B plus A? You put the B first and add the A. Is it going to be the same rate vector?
Yes.
Yes. So A plus B is same as B plus A. Addition, any vector at the beginning and you put the other vector later, doesn't matter. The arrangement doesn't matter. It's going to give the same vector. Okay. So 2D also, if A like this, okay, and B is horizontal, okay, what is A plus B will be? So from the beginning to the end, it's your A plus B. You can do B plus A. You do the B first, B here, and you add the A. Still, it creates the same resultant vector. So A plus B is B plus A. Okay, when you do vector addition, when the question asks for, remember, important, and they say resultant. You want the resultant vector. Resultant for vector. For example, force. A body, you have a body, you have a force here, 3 Newton. You have another force acting down, 4 Newton. They're asking for, find the resultant. Okay, whenever the word resultant is come up, so what is it? Must do vector, what? Vector addition. Must do add them. So these are the two vectors, 3 and 4. You need to add them. So you draw the 3 first to the right. Then the head of the first vector must connect to the tail of the second vector 4 down. then you know this is your resultant. So when you do the resultant, you must do vector addition. Okay, can you put 4 first and later join the 3? You can. You give the same, right? Okay, so vector addition, a plus b is equals to b plus a. Okay, okay. So vector addition is not a big problem one. The problematic one is the next one. What is that? Vector subtraction, a minus b. Okay, so up here you see got a, you got a b. How do you a minus b? So you put the a first, and the tip you join the minus b. So this is a b minus b. So beginning to the end, this is going to be your, the rate is your a minus b. A minus b vector. So you have to convert the second vector, make it minus b. You learned this in your additional maths. Okay, now you tell me, is it a minus b? Is it same as b minus a?
Not the same.
Not the same. How b minus a going to be? You draw the b first, and this is the starting point. Then you have the minus a. Minus a going to be long one. So from here to here, this is going to be your what? B minus a. B minus a. B minus a is different than a minus b in terms of what? The direction. The direction is exactly opposite. So conclusion, don't ever try to do a minus b, b minus a. They are not same. Direction is opposite. Okay? So when this called vector subtraction. When you do vector, this is vector subtraction. When you do vector subtraction, the question asks for changes. Asking for what? When the question asks for changes. Oh my God, sorry. I always forget this. You need to remind me lah, to record it. Sorry. Oh, it's recording. So please, anytime, when I start the class, please help me to remind me. Recording. Okay. So, okay. So a minus b is not same as b minus a. Okay, let's go to the more questions to understand this too. Okay, clear this. Okay, so yeah, what you visualize in this diagram is the vector addition. Okay, so this is u and v. So this vector, the final vector is u plus v. Whenever we draw the vector diagram, make sure the arrow is placed. This arrow and this arrow resultant must write 2 arrows. Okay, 2 arrows to show the resultant. Okay, yeah. So draw the u first, then attach the v, u plus v. So this one, okay, this one more than one vectors. V1 plus V2 plus V3, 3 vectors. So you draw the V1 first, V2 plus V3. From the beginning to the end is your resultant. Okay, you do V2, V1, V3. Any alteration, you see final vector, the R here, the R here, and the R here, all same. Same in terms of what? Same in terms of magnitude. Magnitude same. The length of the arrow same. The direction also same direction. So what you learn from here? Any arrangement will do for addition. Okay. So next problem is the subtraction one. So this is a vector addition. A plus B plus C. These 3 vectors. These 3 vectors, when they added, if you draw a scale diagram, scale diagram means the length, if 5 Newton, you use 5 centimeter of length. You draw it in the correct direction. Okay. So let's say if it makes a closed triangle, what is your conclusion? The resultant force is, what's the conclusion? The resultant force is 0. The resultant vector is 0. Okay. When 3 vectors, when you connect them one after another, if it makes a closed triangle, conclusion means the resultant vector is 0. Okay. So if a body act upon by 3 forces, let's say you have F1 and you have F2 and you have F3. If this system is in equilibrium, means that all the forces F3, F1, when you connect, it must make a what? It must make a closed triangle. Closed triangle, remember. Okay. And the arrow must follow one another. It must move in a circle. Okay. In one direction, in one round. Okay. So equilibrium. Okay. Okay. Before we go to this, I need to show you something. Okay. Share a new screen. I go to the whiteboard. Again, this whiteboard, let me whiteboard. Okay. Okay, I'm going to show the vector changes. Okay. Let's say this is your vector A. Okay, vector A going up. Okay. Vector B is going this way. Okay. Find A minus B. A minus B. Find what is the vector A minus B. So how do you draw A minus B? So A minus B is actually A plus minus B. So what do you have to draw? You draw the vector A first, then you need to add the negative of the vector B. Okay, this is changes. Draw the vector A first. Vector A is going up. Then at the tip, you join which vector? You join negative B. B is to the right, so negative B will be to the B is to the right, so negative B will be to the left.
Left.
So this is your minus B. So from beginning to end, this is your A minus B. Okay. Can you do B minus A?
Yes.
For B minus A. How do you do B minus A? So B minus A is actually B plus minus A. Okay, so draw the B first. At the tip, you join minus A. So B is to the right. Okay. Then at the tip, you join minus A. So A is the up. So minus A will be down. Minus A with the same magnitude. With the same minus A. Okay, then this is going to be your B minus A. Okay. So A minus B not same as B minus A because the direction different. This is upwards, B minus A is downwards. Okay. Okay, now we go to the real physics. Well, how are we going to use changes in vector? Changes in vector, how in physics they're going to ask. One example of question they're going to ask like this. Okay, this one example. A car moved to the north. A car moved to the north with 10 kilometer per hour. Okay, car moved to the north 10 kilometer per hour. The car immediately make a turning to the right with still 10 kilometer per hour of speed. Okay. Okay, so that's car. Car moved to the north 10 kilometer per hour, immediately make to the right 10 kilometer per hour. Now the question is, find the changes in velocity of the car. Find the changes in velocity. Changes. Okay, use the technique I teach you just now. Can you draw the vector diagram? Can you draw the vector diagram for these changes? Can you get the magnitude for me? Most important is the vector diagram. Okay, draw the vector diagram. You do vector addition or vector subtraction?
Subtraction.
Subtraction. You must minus. Because why minus? Because they're asking for change. Okay, so let me wrap up this, some of this. Okay, let me wrap this. I2 on top, yeah. Okay, so maybe I help you. So because you want changes in velocity, changes in velocity means final velocity minus the initial velocity. Okay, changes. So final velocity is plus with what? Negative of the initial velocity. Okay, where's your final velocity here? This is your final velocity. Okay, where's your initial velocity? Your initial velocity. This is your v initial. Okay, so how do you draw the vector diagram? I draw the vector diagram. So you draw what first? Draw the final first. It's like A minus B. It's like A minus B. So draw the final vector first. Vector V final. V final is to the right. Right? So draw the V final to the right. V final to the right. Then the tip you join. Go down or go up?
Is going
Negative for V initial one.
Down.
V initial is up. So negative for V initial is down. So second vector, you have to flip it. It's negative of V initial. So what is your changes from the beginning to the end? The arrow should point down or upwards? Diagonally? Down. Down. Beginning to the end. This is your changes in velocity. Okay. The vector diagram you have to show. Okay. So what is the magnitude of changes in velocity? This is 10. This also 10. So how much this magnitude?
0.
10 squared. Is use Pythagoras theorem. 10 squared plus 10 squared square root. Okay, you have the changes. So it's a root of 100. Root of 200, sorry. Root of 200. Okay, you get the answer in terms of meter per second. Okay. The magnitude is one thing, you get 1 mark. The diagram is carries most of the mark because they can see the direction. So which direction the changes happens? Northwest, southwest, or southeast? Around southeast, right? The changes of velocity happens southeast. Southeast. The direction already shown in the diagram. Okay, so this is changes. When do you do changes? This is the changes, vector subtraction. When you do vector subtraction, and the question asks for changes. Changes of velocity, mainly changes of momentum. Changes of a vector quantity, you must do vector subtraction. What vector minus what vector? Final vector minus initial vector. Okay, final vector you draw as how it was earlier. Initial vector you have to flip it direction. Okay. Okay, this is one example I help you. Okay, I want you to do another one. Okay, you do yourself. Okay, now give 2 minutes for you to try another question. I do that question here. It's going to be the same kind of question. Okay, the question is same the car. The car now move towards east with 20 kilometer per hour. Okay, and it immediately make a turning to the south. 20 kilometer per hour. Please draw the vector diagram. Find the changes in velocity. Find changes in velocity. How's the vector diagram going to look like? Okay, do yourself on a piece of paper. I want you to tell the final direction. Is it going to be northeast, northwest, southeast, or southwest? Okay, 2 minutes for you. Come on. Okay, 2 minutes for you. Must do vector subtraction. Follow the example we did just now. Final vector minus initial vector. Because changes. Okay, so changes. Okay, so is it northeast, northwest, or southeast, southwest? Final vector minus initial vector. So is it southeast, southwest, northeast, northwest? Which direction?
Once.
Southwest, southwest, right? You get southwest?
Yes.
Southwest, so yeah, we're going to make use of this all. Okay. So of course we're going to use this formula. So final minus initial. So final vector is going down. Okay. So final vector is down 20. Then negative of initial vector. Initial vector is to the right. So negative of initial vector is to the left. So 20. Therefore beginning to the end. Okay. This is your changes in the velocity. Okay, so should be southwest, southwest direction. How much the magnitude? As usual, 20 squared, square root. What do you get? 3 SF. The root of how much? Root of 800, right? Root of 800. What do you get? Anyone?
28.284.
28.2. Okay, 28.284. So 28.3 lah. Okay, kilometer per hour. Okay.
We need to write one decimal place only.
We need to write. We follow significant figure. How many
Okay.
significant figure to write? Yeah, sorry. Because I give 20 here. 20 here. And normally in exam, they will give like 2 or 3 SF. So my advice, all the questions, answers, you can write for 3 SF. It will be quite safe.
Okay, thank you.
The data they're going to give in the questions are normally going to be 2 or 3 SF. So you go for 3 SF, I think normally correct. You see, according to Cambridge, let's say you do A times B. You do A times B. You want to get the answer. Let's say A is 2 SF. A is 2 SF. For example, let's say 2.8 centimeter. 2 SF. B, let's say 3 SF. B value is 3 SF. That means, for example, I write 12.4. So 2.8 times 12.4, whatever answer you get, you must, how many SF to write? The rule is follow the least significant among the data is used. The least significant. What is the smallest significant among the data you use? 2 SF, right? So the final answer must follow 2 SF. This is the rule. Okay. Cambridge allow 1 extra SF. So 2 SF or 1 extra. 3 SF is allowed. This is the rule. Okay. What's the rule? Among the data you used, the least significant to be used. Nothing to do with decimal place. Significant figure. Okay. The least significant figure. The least 1 extra is allowed. So tell me, A, you do A plus B, your calculation is A plus B. This is 4 SF and this is 3 SF. So your final answer, you should write how many SF? Right? 3 SF, the least, or 1 extra allowed. 4 SF also allowed. Okay. But I tell you, most of the question papers, the A and B data normally will be 2 SF. 2 SF normally will be 2 SF and 3 SF. So your final answer, you write 3 SF, you get correct. Okay. Okay. So for our last question, I just want you, I want to check whether you understand this concept or not. I go back to this notes. Okay. Under these notes, you have this question. Okay. You can see the question. A ball is like bouncing up. You can see the question? Everyone?
No.
No, you can't.
No.
Can see the question?
Yes.
Okay. So this ball bounces on a surface, 45 degrees. its velocity is v and v bounces up. The magnitude of the velocity is same. Okay, now the question. I pull down the question. This is the question. This is the diagram. Okay, the question is this. Okay, read the question. If you can do this, that means you understand what I teach you about changes in vector. Ball hits the ground at 45 degrees from horizontal. It bounces off as shown above. If the ball mass is m and its speed is v, find the change in momentum of the ball in terms of m and v. If the speed is unchanged after the collision. I already give the answer, it's root 2 mv. But the main thing is the diagram. Can you draw the vector diagram for this and show it should be root 2 mv? Okay, I go back to the diagram. This is the diagram. Okay, this is the diagram. The mass of the ball is m. Okay, it hit with v, it bounces off with v. Make 45, 45. Find changes in momentum. Momentum vector or scalar? Momentum is a vector quantity. So we have to treat as a vector. Okay. So find the changes. Draw the diagram for me, please. Get the diagram. I only get to know your diagram correct or wrong by telling me the direction of the changes. The direction of the changes vector. Is it to the right, to the left, north, or south? Okay. That will tell me that you are correct or wrong. Draw first. Final vector minus initial vector. Okay. I give you a hint, of course, because you want changes in momentum. Momentum symbol we normally put P. Is what? Final vector minus initial vector. Yeah. So it's a vector subtraction. Final vector minus initial vector. Draw the final vector at the tip. Join the negative of the initial vector. You get changes in momentum. Vector subtraction. Okay. So is it the changes? Is it to the right, to the left, north, south? Put like this. North. Changes is to the north. All of you got to the north. Good. So it should be to the north, right? P final. So P final should be plus with negative of P initial. Final momentum is this arrow. This arrow is the final momentum. So you draw the final momentum first. Final momentum moving like this. And unit is mv, mass times velocity. And the angle is supposed to measure here must be 45, 45 degrees. When you draw in scale, you have to measure this angle. Then the tip here, at the tip here, you must join the negative of the P initial. P initial, which direction? This is your P initial. P initial directing downwards, diagonally down. So you must draw up, negative of P initial. Direction change, which the magnitude also mv. So the changes is from the beginning to the end, go up. This is your changes. But when you go up here, you must draw the angle. Okay. This angle also must be, from horizontal must be 45. If this is 45, this is also going to be 45. So you should conclude this is 90. This is actually 90 degrees. So can you find the magnitude of these changes? What is the magnitude of these changes? How much these changes in P magnitude? Use Pythagoras theorem. Okay, theorem Pythagoras. So the changes in P, what? The changes in P squared is equals to what? MB squared plus another MB squared, right? MB squared. These two magnitude lah, MB and MB. Because Pythagoras, right? So end up getting what? You'll get root 2 MB. So the magnitude is root 2 MB. The direction we can see from the diagram is north. The direction is is upwards. It's upward direction. Or we can, so this is how you write the answers. Okay. You do vector subtraction. When you do vector subtraction, and the question asks for changes in velocity, changes in momentum, you must do vector subtraction. Okay. When you do vector addition, and they say resultant. Resultant, you do vector addition. Okay. Any questions? Okay. So this is about this topic. We're done with the first topic. Okay. Done with the first topic. So I'm giving you homework. Okay. So nobody likes homework, but anyway, you have to do homework. Okay. You can see the screen, right? The question. Sorry. Okay, this. Okay, this is another document, the question document, the physical quantity, the third document. This is a passia. Okay, I want you to do these passes. Okay, quite a lot. Okay, the next class we will be discussing about these passias. Okay, you can see the question there. So we're going to discuss these passias. I'm going to choose random question. Okay, randomly the question which is found by your seniors. Okay. Most of the questions, because many years I've experienced these questions, so I go to the questions which the students find difficult. Okay, I want to go through these questions. So today you can give a try these questions. Okay, so tomorrow we're going to discuss this paper, just random questions. Okay, so another 1 hour for this topic. Then the following lesson we go to the next topic. Okay, second topic. Okay, any questions? Anyone have any questions before we stop? No questions, huh? Don't have questions, huh? The class good. Keep it up. You need to be hardworking for Cambridge course. So I believe that you can spend 1 hour today to these questions. Okay. So tomorrow we're going to discuss this paper. Okay. So any problem for you to access in times? You can access in times, eh? So the online classes in the times, or whatever class we are doing today, yesterday, I already posted in the times. Go to scroll down towards the end. You will have online classes. First one is online class for the senior one. You don't need to go for that. The last one, online classes. Okay. Okay. So if you don't have questions, we can stop here. No questions, eh? Okay then. See you. See you tomorrow. Okay. Bye.